Kia ora, year 12 and 13. This is an excellence question from the 2013 differentiation paper. It's about a cylindrical tank. It's probably the easiest excellence question in the old papers that we've got for this standard, so hopefully this will be a nice short video. Alright, we've got a closed cylindrical tank, which we'll draw, and it's going to have a surface area of 20 metres squared. Find the radius the tank needs to have so that the volume it can hold is as large as possible. So we know we're going to be working with two things. Surface area for a cylinder is given by this formula, 2 pi r squared plus 2 pi rh. Now you probably don't really care because that is in the formula sheet, but just have a quick look at it. This bit here is the area of the top surface and the bottom one, and this bit here is the area of the rectangle you get. So if you visualise the net from that cylinder, which you probably did back in year 9, that's this bit here. And we know that that's going to be equal to 20. So 20 equals 2 pi r squared plus 2 pi r times h, divide through by 2, 10 equals pi r squared plus pi rh. Right, so put that to one side, just as if you're baking a cake or something. And now look at the next bit. We're going to look for volume, and we want to maximise the volume. So the formula for the volume of a cylinder is pi r squared h. Right, again, just take a quick look. That's the base of it, right, pi r squared times h, the height. We want to maximise this. We are in year 13 and year 12, so we can't work with two variables in our functions, so we need to get rid of either the r or the h. We're going to do that by going back up here and rearranging this, and we might as well make h the subject here. So we're going to go h equals da da da, and then we're going to substitute that in here, and then we're going to maximise v. Right, so we've got 10 is equal to pi r squared plus pi rh. H is equal to 10 minus pi r squared divided by pi r. So h is equal to 10 over pi r minus the next bit here, just simplifies to r. Right, we want to substitute that in now to the volume of a cylinder, which is pi r squared h. We'll sub in our expression for h. Okay, I'm going to try and squeeze this in here. So expanding, we get v is equal to 10 r for the first bit minus pi r cubed. Alright, so the volume of our cylinder must equal 10r minus pi r cubed, and we want to maximise that volume. So for a maximum volume, we require the first derivative with respect to r to be equal to 0. So dv by dr is equal to 10 minus 3 pi r squared. We need that to be equal to 0. So we're going to solve this. We'll get r squared is equal to 10 over 3 pi. So the radius is going to equal plus or minus 10 over 3 pi. So that's the algebraic solution. Again, I'm going to squeeze onto the one slide to speed up the video, but r is equal to 1.03 metres, and we ignore r equals negative 1.03 metres because of the context, right? We can't have a cylindrical tank that's got a negative radius. Okay, so that is it. Okay, all you have to do was to find the radius. You didn't even need to go back in and find the volume for that radius. Thanks for watching. I will be back with the next excellence question from 2013 in about half an hour.